On the night of February 24, 1944, over Anzio, Italy, the sky was dark. Two full SCR-584 units were hurried into the confusion and buried up to their trailer tops during the night. The following evening, 12 Nazi bombers flew into the beachhead's airspace. Before we continue, show your support by subscribing and letting me know where you're watching from. 7 of those bombers were lost to the 90mm guns, guided by the SCR-584. The math of that night would confuse German intelligence for the rest of the war. 7 out of 12 bombers shot down in total darkness. That's a 58% kill rate, which went against everything known about fighting aircraft from the ground. Before that night, even in clear daylight, anti-aircraft guns usually got 1 kill for every 2,500 shells they fired. The German crews who survived reported something they had never seen before: anti-aircraft shells that followed their every move, explosions that happened exactly where their planes would be just seconds later. It was as if the gunfire could predict what they were going to do before they did it. What brought down these planes wasn't better aim or lucky shots. It was the SCR-584, a microwave radar system that tracked targets automatically and would completely change air defense. This new technology would stay mostly unknown to the German military for the whole war, even as it gradually wore down the German Air Force's ability to fight. The Germans had flown into the future of warfare, and they had no idea. The trouble for the German Air Force had been growing since 1940. That's when British scientists shared a special device, the cavity magnetron, with America. The British scientists brought their top-secret invention, which was the key to making the powerful radar systems they wanted. This one act of sharing technology would have results that neither side fully expected. While Germany kept developing radar in the old ways, using longer radio waves, American engineers at MIT were creating something groundbreaking. The SCR-584 was a wonder of its day. It could spot a plane from 40 miles away and was accurate within 75 feet. The system used microwave frequencies that German detection gear simply couldn't notice. It operated at very high frequencies, sending out strong, short pulses of energy over 1/700 times a second. German warning devices, which were made to find British radars using much lower frequencies, were totally blind to these signals. The technology gap was bigger than just different frequencies. The SCR-584 used automatic tracking with a special scanning method. The radar beam spun around, making a cone shape that could lock onto a moving target and follow it without a person's help. When connected to the M9 gun director, a type of analog computer with 160 vacuum tubes, the system could figure out where to shoot 30 times every second. It took into account wind speed, air thickness, the target speed, and gravity. The use of this system at Anzio was a major turning point in anti-aircraft combat. Air raids stopped for a whole week. When one plane showed up to test the defenses, it was shot down immediately. 10 more systems were put in place that week, which ended the threat of air attacks on Anzio. German bomber crews, who had been successfully bombing Allied areas for years, were now up against something they had never experienced. The system worked so well because it was completely automated. Once an SCR-584 operator found a target and switched to automatic mode, the radar locked on and followed the plane no matter what dodging moves it made. The tracking information went straight to the M9 director, which calculated the future spot where the shell and the plane would meet. 4 90mm guns linked to the director moved together perfectly. German pilots described something they couldn't figure out: anti-aircraft fire that seemed to know their next move. When they dived, shells exploded where they would be at the end of the dive. When they turned, explosions burst along their future path. This wasn't the scattered fire they were used to. This was precise shooting by machines that could think faster than any person could. While German scientists built radar sets by hand in small shops, American factories were mass-producing the SCR-584 with car factory speed. About 1,700 of these workhorse systems were made to defend against air attacks. The main maker, Chrysler, used assembly lines that changed radar production from a craft into a large-scale industrial process. By August 31, 1943, 610 systems had been sent out. The Dodge Division delivered the 1,470th system on January 28, 1944, and many more went to other branches, for a total of nearly 3,000. This one company made more radar units than Germany did during the entire war. The difference showed a deep contrast in how the two countries approached manufacturing. German Würzburg radar sets needed skilled workers to put them together, and each one was a little different. The SCR-584 used standard parts that could be swapped out, letting soldiers with little training make quick repairs in the field. Where Germany built a few dozen, America built thousands. The D-Day invasion on June 6, 1944, had 39 of these systems, stopping German air attacks on the beaches. These radar units, specially waterproofed for the sea-to-land attack, created a protective shield over the largest invasion fleet in history. Oberst Joseph Pips Priller, one of only 2 German pilots to attack the beaches on D-Day, lived to tell about it. In an interview after the war, he talked about anti-aircraft fire that was unlike anything he had seen in 5 years of fighting. It wasn't random patterns of fire, but aimed shots that forced him to keep dodging, making it impossible to attack accurately. The German Air Force's failure at Normandy wasn't because of a lack of bravery or talent. German pilots flew into a technology trap they couldn't understand. The few who made it back reported the same thing seen at Anzio, anti-aircraft fire that seemed to read their minds, predicting their moves before they made them. The defense against Hitler's V-1 revenge weapons showed the clearest example of the SCR-584's game-changing abilities. These flying bombs, which traveled at 400 mph in a straight line at a steady height, should have been easy targets, but their speed made them almost impossible to hit with normal aiming. 20 SCR-584s were sent to England's coast to reduce the number of V-1s hitting London. The 80 guns, using new shells with proximity fuses, shot down hundreds. On one Sunday, 97 out of 101 were destroyed in the sky. The numbers showed a complete change in how effective anti-aircraft fire could be. In the first week, 17% of all flying bombs that entered the coastal gun zone were destroyed. By late August, that number rose to 60% and then to 74% in the last week of the month. On one amazing day, 82% were shot down. The rate went from 1 V-1 for every 2,500 shells to 1 for every 100. This 25 times improvement in ammo use was more than just a small step forward. It was the moment when defensive weapons became better than attacking planes. German spotters on the French coast saw V-1s being destroyed with short, accurate bursts of 3 or 4 shells, a sight that went against everything they knew about anti-aircraft fighting. The Germans' failure to see the threat from the SCR-584 came from a basic scientific mistake. In January 1943, German radar experts, led by Professor Abraham Esau, convinced their leaders that centimeter-wave radar was not physically possible. They claimed that not enough energy would bounce back to a receiver at such high frequencies to be useful for spotting targets. Based on this wrong theory, Germany stopped all microwave radar research. When German troops captured a British H-2S radar in February 1943 and found it used centimeter waves, the discovery came too late. Germany was already years behind in microwave technology, a gap they could not close during the war. German intelligence always misunderstood the growing proof of the Allies' superior radar. Pilot reports of impossibly accurate anti-aircraft fire were blamed on better training, new sights, or just having more guns. The idea that Americans had achieved automatic radar tracking at microwave frequencies was something the Germans couldn't even imagine until late in 1944. Throughout 1944, German electronic warfare teams used equipment made for an earlier time. Their detectors searched for frequencies that were far too low to find the SCR-584. Even their more advanced detectors, which were closer to the right range, still couldn't reliably pick up the signals. More importantly, German detectors were built to find search radars that swept a beam across a plane for a moment. The SCR-584's cone-shaped scan, which kept a continuous lock on one target, made a signal pattern that German equipment didn't see as a threat. German air. Crews flew into radar-guided death traps while their warning systems stayed quiet. The system made by Chrysler was called the SCR-584. It was paired with a heavy anti-aircraft battery of 4 90mm guns, a British-made IFF, identification, friend or foe unit, a power generator, and an M9 gun director. Each part showed America's engineering strength. The cavity magnetron created 300 kilowatts of microwave power, more than entire German radar stations. The motors for the automatic tracking were so precise that German industry couldn't match them. The M9 director did the complex math for aiming that would have needed whole teams of human calculators. Putting all these technologies together into one weapon system was a big new idea that the German military hadn't thought of. Labeled the SCR-584 anti-aircraft gun-laying system, about 1,500 of them were used in Europe and the Pacific starting in early 1944. Each system could track planes flying at 600 mph faster than any plane in use in 1944. This forward-thinking design proved useful when German jets started to appear. By mid-1944, the German Air Force was facing losses they couldn't handle. A top general, Galland, reported that one air fleet had lost 38% of its fighter pilots in April 1944, while another had lost 24%. In total, the Germans had lost 489 pilots, including 100 officers, while training schools had only sent 396 new pilots to replace them. These losses weren't just from dogfights. More and more, skilled pilots were being shot down by anti-aircraft fire that was incredibly accurate. Ground attack planes, which were key to German Army tactics, became especially easy targets when they flew inside the SCR-584's best tracking range. Adolf Galland, in his book written after the war, said, "By 1944, getting close to Allied positions meant flying into areas where death was figured out by math. The guns didn't aim at where we were, but where we were going to be. There were no tactics against it, no way to counter it, only luck." In December 1944, during the Battle of the Bulge, German troops finally captured a damaged but whole SCR-584. Dr. Hans Hollmann, Germany's top radar expert, led the team that looked at it. His report to the High Command was crushing. The Americans have achieved automatic tracking with an accuracy we thought was impossible. They use wavelengths we can't detect or jam with our current equipment. Most importantly, they mass-produce these systems while we have trouble building lab models. We are not just months behind. We are years behind, with no chance of catching up. The captured system showed new ideas that German science had thought to be impossible in theory. Automatic tracking that stayed locked on despite a target's moves, electronic calculation of firing solutions in 3 dimensions, and smooth connection of radar, computer, and guns. But this information came too late to create any countermeasures or similar systems. The feeling of being technologically helpless that German pilots felt led to a revolt by fighter pilots in January 1945. Top aces, including Adolf Galland, confronted Hermann Göring directly about their impossible situation. Johannes Steinhoff, with 176 confirmed kills, told Göring, "We are not fighting enemy pilots anymore. We are fighting math calculated by machines. A pilot's skill doesn't matter against automation. You say we lack courage, but courage can't beat technology that we don't have." These men were not quitters. They were Germany's most celebrated heroes. Their realization that old military values were now useless against automated weapons was a deep mental breakdown. Göring's reaction, firing Galen from his command and threatening him with a court-martial, showed that the leadership couldn't accept the technological reality. Even the groundbreaking Me-262 jet fighter was no match for the fire directed by the SCR-584. The jet's 540 mph speed, which made it almost impossible for Allied fighters to catch, meant nothing to a radar system designed to track targets at 600 mph. An officer who was one of Germany's best jet pilots reported after the war, "We thought our speed would save us from anti-aircraft fire. Instead, we found out the American guns tracked us perfectly. The shells got there exactly where we were headed. Speed just meant we had less time to dodge. We lost several jets to anti-aircraft fire that was unbelievably accurate." The SCR-584's ability to track and destroy jet aircraft showed a level of foresight in American planning that the Germans did not have. It was built to standards that were higher than any plane flying in 1942, so it was still effective against technology that didn't show up until late 1944. The production numbers showed a difference in factory power that doomed Germany, no matter what new tactics they tried. American production by Chrysler Corporation alone was nearly 3,000 units. The total confirmed production was at least over 1,700 units, with more from other companies. The cost per unit dropped from $50,000 to under $10,000. At their peak, they were making over 50 units a month. For German production, the total for the Würzburg radar was about 1,500 units over the entire war. All German radar types combined were about 4,000 units. Each one was basically built by hand, with no major cost savings. Production was limited for the whole war. This gap showed deeper strengths in America's industrial culture. The SCR-584 was designed so that drafted citizens with only 6 weeks of training could operate it. German radar systems needed engineers and technicians who had months of special training. Besides the technical details, the SCR-584 had practical strengths that made it even more effective. It could be set up and ready to use within 30 minutes of arriving, while German systems took hours. This ability to move quickly was vital in the fast-moving campaign in Italy, where the SCR-584 gave instant air defense to advancing troops. It worked in rain, snow, and fog that made optical sights useless. German radar did not work well in bad weather. Its simple, modular design meant that operators could replace parts themselves. German systems needed special technicians for even small repairs. It only needed 3 operators compared to 8 for the German system. Field Marshal Albert Kesselring said after the war, "American radar-controlled anti-aircraft fire made our tactical air support impossible by early 1944. The German army, which had been a leader in combined arms warfare, was now fighting blind while the Allies could see everything from the air." The campaign against the V-1 flying bombs gave measurable proof of this revolutionary progress. In the first week, the success rate was 17% using old methods. By week 4, it was 60%. By week 8, the average success rate was 74%, with the best day hitting 82%. Ammunition use improved 25 times over. These numbers marked the first time in war that defensive guns were consistently better than attacking planes. The V-1, a simple cruise missile, flew in predictable ways that should have made it an easy target, but its 400 mph speed had made it almost untouchable by normal anti-aircraft methods. The SCR-584 changed that picture completely. German electronic warfare, which had worked well against British radars early in the war, was totally useless against the SCR-584. The German Air Force's advanced jamming gear, which worked on longer wavelengths, had no effect on microwave systems. German chaff, or foil strips cut for those same long wavelengths, was also useless. The failure was about more than just equipment. German electronic warfare strategy assumed their enemies were using similar technology. The idea that the Americans were operating on totally different physical principles was not considered until captured equipment showed them the truth. By that time, Germany didn't have the resources or the time to develop new ways to counter it. The SCR-584's impact went beyond the planes it shot down. By making German spy flights impossible, it blinded the German Army's intelligence. German commanders couldn't see Allied preparations, track troop movements, or find weak spots. This lack of information directly led to German strategic mistakes throughout 1944 and 1945. General Hasso von Manteuffel, who commanded the 5th Panzer Army during the Battle of the Bulge, said, "We attacked blind in the Ardennes. Our reconnaissance planes couldn't survive over Allied lines. We knew nothing of enemy reserves or movements. The element of surprise, which was essential to our plan, was impossible when only one side could see." For the German air crews, the SCR-584 was something psychologically crushing. It was death delivered by machines that took human skill out of the fight. Pilots who had trained for years, flown hundreds of missions, and won their country's highest medals found themselves powerless against automation. The words of those who survived show the mental impact. Hermann Graf, who ended the war with over 200 victories, said, "Fighting enemy pilots was war as we knew it. Skill against skill, courage against courage." But the radar-guided guns weren't warfare. They were execution by mathematics. There was no honor in dying to a machine's calculations. This removal of the human element from combat hurt morale more than just the fear of death. German pilots had accepted that dying was part of being a warrior. What they couldn't accept was being irrelevant, their skills and experience reduced to meaningless numbers in an equation they couldn't change. After Germany surrendered, Allied intelligence officers showed the SCR-584 to captured German officers. Their reactions went from shock to sad understanding. Many said they were relieved to finally know what they had been up against. Dr. Wilhelm Runge, who had worked on German radar, admitted in 1985, "We ignored every report that didn't fit our ideas about American abilities. We came up with complex theories to explain the impossible anti-aircraft accuracy instead of accepting the simple truth. They had better technology." This pride cost thousands of lives. The German military's inability as an organization to admit American technological strength came from deeper cultural beliefs. The German Army, which had been a leader in military innovation in the 1930s, couldn't believe that American engineers had surpassed German science. This blindness continued even as more and more proof appeared throughout 1944. After the war, the radar was adapted for use in missile systems for the U.S. Army. The principles started by the SCR-584, automatic tracking, computer-controlled prediction, and integrating systems, became the foundation for all future air defense systems. Every modern surface-to-air missile system is conceptually descended from the SCR-584. It proved that to have effective air defense, you had to take human reaction time out of the process. This lesson, learned through the destruction of the German Air Force's fighting ability, shaped military technology for the Cold War and after. While exact numbers are hard to find because wartime records were destroyed, the data we have shows the SCR-584's crushing effectiveness. A minimum of 1,700 units were confirmed to be produced, with Chrysler alone making nearly 3,000. At its peak, over 50 units were made each month. In combat on the first night at Anzio, 7 of 12 bombers were shot down, a 58% kill rate. Against the V-1s, the peak performance was an 82% success rate, with a 25 times improvement in ammunition use. For D-Day, 39 units provided complete air defense. Technologically, it could detect planes from 40 miles away, double the German ability. It was accurate to within 75 feet, compared to over 500 feet for the Germans. Tracking was fully automatic, while the Germans had to do it by hand. Setup time was 30 minutes versus over 2 hours for the Germans. The Germans' experience with the SCR-584 offers lasting lessons about being surprised by technology in war. Convinced they were superior, limited by their own scientific theories, and unable to imagine American innovation, German leaders sent their air crews to face a threat they didn't understand and couldn't fight. General der Flieger Paul Deichmann summed up the failure. "We believed what we wanted to believe. Every piece of evidence to the contrary was explained away. We couldn't accept that American engineers had done what our scientists said was impossible. By the time we faced the truth, the Luftwaffe as a real fighting force was gone." The failure wasn't mainly in gathering intelligence, but in understanding it. German observers correctly reported how effective American anti-aircraft fire was. The reports were ignored because they didn't fit the leadership's beliefs about American capabilities. This inability to see the truth was more harmful than any security leak could have been. The SCR-584 was a product of American industrial thinking, mass production, standardization, and making things simple. Instead of creating perfect individual units, American engineers designed for reliable mass manufacturing. This method, taken from car production, turned out to be better for military use than Germany's focus on expert craftsmanship. The difference was also seen in how they operated. German military culture valued expertise and specialization. American design focused on simplicity and automation. The SCR-584 was successful because it took human skill out of the process, making expertise unnecessary. This approach of making advanced technology easy for anyone to use was decisive in a total war. The SCR-584 marked the end of air combat as a contest of human skill. It started the age of automated fighting that we see today. For the German Air Force, this change was a shock they couldn't understand. They started the war as knights of the sky and ended it as victims of mathematical calculations. Johannes Steinhoff, looking back decades after the war, gave what might be the most telling summary. The SCR-584 didn't just shoot down our planes. It shot down our whole idea of war. We thought war was about courage, skill, and willpower. The Americans proved it was about technology, production, and automation. We were magnificent warriors defeated by superior machines. The SCR-584 radar system is one of World War II's most important weapons, not just for the planes it destroyed, but for what it stood for: the victory of systematic technological strength over traditional military values. The German Air Force faced an enemy that couldn't miss because it removed human error from the aiming process. German pilots never fully knew what they were up against because their leaders couldn't accept that it existed. Reports of impossibly accurate anti-aircraft fire were dismissed as overstatements. Proof of automatic tracking was ignored as impossible. By the time German scientists looked at captured SCR-584 units and understood the technology, the German Air Force had been rendered ineffective. The Germans never knew American radar devastated their Air Force because admitting that truth would have meant admitting they were fundamentally behind in science, industry, and military innovation. That mental block was too big to overcome until defeat made it impossible to deny. For the German air crews who faced it, the SCR-584 was death calculated by machines, delivered with mathematical precision and unaffected by human courage or skill. They flew into an electronic killing field where their fate was figured out before they even got there. The age of warrior pilots ended in the skies over Europe, destroyed by American radar that tracked without being seen, calculated instantly, and killed automatically. The legacy of the SCR-584 goes far beyond its wartime use. It set the pattern for modern air defense and proved that in a technological war, the side that automates the kill chain wins. The German Air Force learned this lesson through the destruction of its fighting power, one plane at a time, calculated and delivered by machines that never got tired, never missed, and never knew mercy. The Germans never knew, until it was too late, that they weren't fighting American gunners, but American mathematics brought to life in radar systems that turned the sky itself into a computed killing zone. Their courage, skill, and experience became meaningless factors in equations they couldn't see, couldn't jam, and couldn't survive. In that terrible realization lay the birth of modern warfare, where victory belongs not to the brave, but to the technologically superior.